We're just going to dive right into introducing our next speaker. He recently became a dual citizen of both the United States and the Republic of Ireland. Everyone, please welcome our opening act, Will.
Well, welcome everyone. Always fun to be the first speaker at a conference. Get the speaking out of the way, the accolades, all of the crowd rushing you throughout it's great. Well, thank you. Welcome. It's great to be here. My name is Will Doane. I am Assistant Director at the Science and Technology Policy Institute, which is a federally funded research and development center located in downtown Washington, D.C. We are managed by the Institute for Defense Analysis, or IDA. You'll be seeing a number of people associated with IDA throughout the conference. Feel free to accost any of us and ask us about what we do. STPI in particular is a little strange in the FFRDC space. We're the only FFRDC that was chartered by Congress to support another agency. We support the White House Office of Science and Technology Policy. We provide them with sort of stable, ongoing, non-political, objective, rigorous research related to science and technology policy issues. We also work across the federal government with any agency that has an S&T mission. Today, I wanted to talk to you a little bit about a relatively new agglomeration of tools for me, Text Explorer. I've been doing NLP for 12, 13 years now, but I'm always frustrated that it feels so bespoke and that it's relatively challenging to bring non-technical people along for the ride and to give them the tools they need to be successful grappling with some NLP, natural language processing, for those of you in the room who have somehow managed to avoid that acronym. At the corporate level, we have heavy lift resources where you have a stable corpus of work, a large collection of documents that's going to stay relatively constant over time, where you need heavy compute lift for it. We have that. That is not this. This is more for the desktop user, for small to medium-sized analyses, where maybe you've got dozens, hundreds, thousands, tens of thousands of documents that you're looking at, something that's relatively modest, not big data, where the corpus is likely to change in a very dynamic way. Sponsors are giving you new data on the fly. New documents are being released all of the time. If you're watching, are we calling them X's now instead of tweets? What do we, if you're watching noise channel social media, and you need to just constantly be ingesting that information, that just doesn't always work so well for us with the heavy compute resource. So this is meant to be a smaller, dynamic, agile tool that allows people to work at their desktop as an endpoint. Critically for us, it's also, trying to remember whether I'd put it on this particular slide, but it's meant to work either at an unclassified or a secret level. Doesn't require coding knowledge, does require that you be able to go to a code repository, download a zip file, unzip it, and double click on our proj file, right? So a little bit of lift there. It relies mostly on frequentist, and meaning we count things, and latent Dirichlet allocation kinds of analyses. We're not leaning on the generative AI models here. We're not having systems with GPUs at the end user's position that we're going to be doing heavy language model lifts on here, nor in the national security context can we tolerate having queries and document stores being sent out over the network to AWS or other services in order to crunch the numbers that are necessary. So for us, if you have R in RStudio installed, you download this zip file that has, it's an RStudio project, it has the code in it, has some sample data projects in it. You click run for the Shiny app, and all of your documents are then accessed locally. So this is a little unusual for Shiny applications. Thought I was hearing a little feedback. It's just a moving truck out back, apparently. So, you know, maybe you're dealing with tens of megabytes or hundreds of megabytes or gigabytes of data, but you don't want to be shuffling that around your network every time you run the Shiny app. So we leverage a package called Shiny Files that allows you to access the user's local file system. So you're running the app locally. Your data is local, or at least on a locally accessible drive. I'll show you that in a moment. So that for those applications where you're sensitive about your data, where it might live, you're not having to upload it into a database somewhere where someone else might have access to it, or upload it to a server where you don't know the provenance of the server. So this is what it looks like. This is not vaporware, it's real, we use it. You can see if you're really keen on the upper banner there that it's running 127.0.0.1, it's running on localhost, so local to the user's machine. Along the left, you have a tremendous number of configuration options. Standard things toward the top. I'm not scrolling down for them here. To avoid the dangers of live demos and network access and all of that, this will be static screenshots of content, so sorry about that. But you have standard cleaning options that are pre-configured for you in the way that we've found most useful in our analysis use cases. Down below, there are additional options for topic model configurations, n-gram configuration, tokenization configuration that you might get into. Again, they're all pre-configured in a pretty robust way, but you can tweak those if you're finding that you're not getting the results that you are hoping for. You can have standard stop word removal. You can have custom stop word removal. You may notice throughout the interface, these little, yep, they're visible up there, the I circle info button. For technical terminology, there are help links throughout the interface that point you to canonical resources to train you up on those bits of terminology, methods of analysis if you are not familiar with it. But this is the user's landing page. This is the start page. We have a slightly quirky list of file types that we support by default. Usually PDFs, Word docs, and CSV files are the core for folks. But I'm a coder, and I like to analyze my own stuff. So I also use these tools to pore over code databases or code repositories that I've downloaded. User selects a folder somewhere that's locally accessible on their file system. They initially are put into one of several different drive configurations, depending on what computing platform they're on. But it will, this is for a Windows system, it will seek out the different drive mappings that you have on your system. So anything you have mapped to a drive letter is available to you immediately. For the uninitiated NLP users, the README file is also embedded as the help about page within the app. So you can get, without having to go back to a code repository and read a README file, you can get access to all of the tutorial information from how to set up, what the configuration options mean, how to use the tool for analyses and so on. I'll show you a couple more of those later on in the, those help items later in the talk. So the user selects an appropriate location. The tool will search recursively whatever directory you select. So if you have a structure within your collection of documents, for example, this has Federal Register documents. I went out to the Federal Register, which is the publication venue of record for the federal government, and downloaded all of the presidential archives from 1999 to the present day. They're sorted into various subfolders by each year. So when I import those, I get those document names complete with those subdirectory names, labels associated with them, so that if I wanted to subset this and look at just a particular year's content, I could do that. Once the users select an archive folder, then the documents are read in. They start to be tokenized. The way the interface is set up, it's sort of least complicated, select a document store, what's the corpus, through some simple frequentist, let's count some things, up to topic modeling. Each of those caches their results along the way so that the user benefits from having looked at any one of those things. So you're not repeatedly pre-computing tokens. You're not repeatedly pre-computing n-grams of various sizes. And all of that's just using Shiny's bind cache capabilities, the standard built-in caching functions. That cache gets stored, as a technical detail for you, that cache gets stored in the folder that you selected as your corpus. So any other user who also selects that folder will benefit from those cached results. The cache is invalidated when the set of documents in the corpus changes. So a lot of dynamic behavior there. You have access to frequency counts within documents, both absolute and relative frequency counts. You have access to term frequency, inverse document frequency kinds of metrics. It's off screen here, but any table that you see in the application can be downloaded as a CSV file so that you can go and analyze it elsewhere if you want to. If you click one of those results, it brings up the text of that document and highlights the term that you selected. So for example, here, you've got on that first row, active duty is the n-gram, the term that was selected. It occurred 3 times across 178 documents. It occurred 3 times within this document, 178 times in total across the corpus, 30 different documents, representing about 3% of the documents in this corpus, which was 1,011 documents. It highlights it, gives you a handy little next button that will scroll down, advance the page for you, so you can quickly search through and see whether or not you're seeing the phrases that you expect in the contexts that you expect. It's a fuzzy match, so active military duty would also get flagged here in addition to active duty. Right? You get a separate set of metrics that are sort of across the corpus, across documents, so you can see those counts just by term. So there's no reference to a particular document here. If you click one of those rows, you get back the list of all the documents that have that term in it. So you can hunt those down, decide what you want to do with those. Those are, by the way, the default file names that come from Federal Register, not my clever naming convention. You can use the column filters to say, look, I'm not interested in things that only occur once or that occur 1,000,000 times. Let's narrow that span a little bit. That's just standard data table behavior in Shiny. So you get all of that as a benefit. Let me see here. Keyword in context tool. You're interested in looking at legislation and finding all of the places that the word shall was used and seeing what was said on either side of that. It's typically referred to as keyword in context, or KWIC, quick. So you can do those kinds of quick searches here, and you can tweak the degree of context that you have, how many terms on either side of the key phrase that you are interested in. And again, if you click any of those, it'll take you directly into those documents and show you where that term was being used. And again, it's downloadable, so you can start analyzing this elsewhere. There's a keyword tagger built in, which basically just takes a list of regex and spits back a spreadsheet that says, here are the documents, here is a column for each of the patterns that you searched for, and here are the documents where that appeared, true, false. You can download that and work with that separately. Or you can filter that in browser and say, just show me the things where this is true or where this is false. Sentiment analysis. I don't find it tremendously useful on the kinds of documents that we're working with. It's federal government after all. But it's there if anyone wants to use it, both pictorially. You can see positive and negative sentiment here in the blue and the red, the above the line, the below the line differences. Each of the facets of this, the gray bars, is a separate document. And so they vary based on how long the width of the bars in these vary based on how many utterances, how many subunits there are within a given document. Shorter documents have wider bars. Longer documents will have narrower bars. But you can also download that as a table, complete with the sentiment score, which you can filter. So if you're only interested in looking at those things that are negative sentiment, you could go from negative whatever the score is to 0, or if you're only interested in the positive, from 0 to positive infinity. Topic modeling is built in. Is Tommy here yet? Tommy Jones will be here tomorrow. And Tommy wrote a package called Tidy LDA. He's written several different topic modeling packages, but we're leveraging that particular one from him here. Tommy used to work with me at IDA and is now off on his own as an entrepreneur. Go to his talk too. The topic modeling is based on latent Dirichlet allocation, but you get an R-square value up front to tell you a little bit whether your model is any good or not, as well as prevalence and coherence scores to tell you whether or not the particular topics that are being generated represent large portions of your corpus and are robust across multiple probabilistic samples from your corpus. And you get a convergence diagram that will help you understand. So in this one, the models were iterated over 200 times. By about the 50th iteration, the models were stabilizing. We were starting to see the same results come up. So we've got convergence, we've got high prevalence, we've got reasonable coherence, and for textual, unstructured textual data from a corpus that I haven't planned on, pretty good R-square value for explainability here. You get the top terms in the topics. You can look at those separately. Download that table if you're interested in that selection. They're in order here within each of the topics. I haven't done any custom filtering here, so you may notice some of the n-grams are showing up in multiple topics. It's not an exclusive categorization of the terms. Similarly, you can look at the documents that are associated with each topic, get those lists. And again, all of this is downloadable. I've embedded LDA viz, if you've ever worked with that package from way back when. Had to do a little bit of work to fix the data formats going from tidy format to LDA viz, but once that's worked out, this gives you a sense of which topics contain which topics contain which terms, what percentage of the topics are occurring within each term. This is an interactive element. You can mouse over the topics, 1, 2, 3, 4, the bubbles, and then mouse over the topics on the right-hand side to see which topics contain each of those terms. So again, it gives you that sort of quick analyst. I didn't need to know a lot, but if you want to know more about the technical detail behind this, the methodological justification for this, there is a link out to the original LDA viz demos and introduction papers. There are also UMAP projections, if you're familiar with the UMAP dimensionality reduction algorithms. This takes whatever dimensional space you have and projects it down onto a smaller dimensional representation, in this case to 3 space. That's interactive, so you can spin, zoom, pan, select a particular topic. Here there are 5 topics. If you click any of the topics on the right, it'll select just that topic out of the set so that you can then focus on that topic. If you select any point, each point here represents a document in this abstract UMAP 3 space. If you click, and the colors represent the topics, et cetera, et cetera. If you click any one point, you get that document representation on the left, and you get the k nearest neighbors on the right. All of those elements like k nearest neighbors, what counts as k, are configurable from the left-hand options panel. And of course, everyone in federal government loves their word clouds. So I was ordered to put in a word cloud generator. There it is. It's a word cloud generator. You can have it in black and white for reproducibility purposes, or you can generate it in color if you're just looking for something nice and bright and shiny to put in your lowercase s, to put in your PowerPoint presentations. This is also a great tool, I have to admit. Looking at the data this way, great tool for figuring out what your custom stop words should be. Nothing like having a nice big word on screen that you don't care about to say, oh, let's ignore that. Built into the tool is an option under help for standard session information. Number 1, I don't show that here, but standard R session information so that you can document the tools and the versions of the packages and the version of R and the OS and the memory configuration and so on that you have on the system. But also this, the how to cite. I've overridden the library command and the citation command in R so that when you library all of your packages at the beginning of running the app, it gathers all of the citation data and presents it in this UI complete with the bib text and the formatted version of a citation to encourage people to cite the tools that they're using. Whichever subset of these packages you're reliant upon, include those citations in your papers is the standard message there. Those packages, there you go. Small sample of what's in there. And my contact information should you want to ask any questions about this tool. This is not available on a public repository right now, but I'm happy to talk about it, maybe even push in that direction. Thank you.